This lesson is for Advanced Algebra, Lesson 8.6 on simplifying radicals. Students will need a baby calculator only. It's real important that students remember that when you multiply a square root of something times itself, that the radical symbol or the square root symbol will cancel out, giving you just that number back. Radicals, or that radical symbol, are not allowed in the bottoms of fractions. So you have to do something called rationalizing the denominator. Students do need to recognize that statement as it will be written specifically in questions. So it'll say simplify by rationalizing the denominator. So there's two methods for doing it. The first type is the easy type. When there's a radical on the bottom, multiply the top and the bottom by that radical. So this would be your original problem here, 30 over square root of 10. Because the radical 10 is not allowed on the bottom, we multiply by radical 10 on the top and the bottom. Notice that radical 10 divided by itself is just going to be simply multiplying by a 1. When you do radical 10 times itself on the bottom, the radicals cancel, giving you just a 10. On the top, the 30 and the radical 10 end up being right next to each other, and then the 30 and the 10 on the bottom can reduce to just a 3. That's the basic process of rationalizing the denominator when there is a radical on the bottom. Let's try some other practice questions. Let's say we're asked to simplify 6 over the square root of 9x cubed. Whatever the radical is, we need to multiply by that on the top and the bottom. So I'm going to multiply by radical 9x cubed on the top and the bottom. Keep in mind that the 9 and the x and the cube are all under the bar, so make sure you make your bar big enough. If you only make it so that it looks like it's over the 9, that would not be correct. Now on the bottom, when you multiply radical 9x cubed by itself, the radical sign cancels, leaving you just 9x cubed. On the top we've got a 6, still sitting there. And now we know we can simplify the 9 and the x cubed a little bit further, so I'm going to break those up so that they each get their own separate radical. And what you'll find is that square root of 9 makes a 3, and that is supposed to be multiplying by the 6. We'll put a times symbol in there and put a 3. The radical x cubed can be simplified down to x squared and x. The exponents here have to add up to 3, but one of them needs to divide by the 2 because it's a square root. And then on the bottom we still have our 9x cubed. So the 6 and the 3 there becomes 18. And the x squared here is divided by the 2 as the root, so that just becomes an x outside the radical. And then we've got the square root of x still under the radical. And then the 9x cubed. Now that we've simplified completely on the top and the bottom, now you want to simplify vertically. The numbers, 18 and 9, can reduce to a 2, and the letters, the x and the x cubed, those can reduce as well. So let's see what happens there. If we do 18 over 9, that's a 2 on the top, or 2 over 1. There's one x on the top and there's 3 x's on the bottom, so that leaves me 2 x's on the bottom. And then the radical x is still on the top. And that's my final answer. So let's try another one. Simplify 2t over radical 8t to the 5th. Whatever that radical is, I'm going to multiply by that on the top and the bottom. On the bottom when I multiply, the radical cancels, leaving you just 8t to the 5th. On the top I've got my 2t, and now I'm going to break up the pieces separately. So I've got 8 and I've got t to the 5th. So now let's look at the 8. The 8 can be simplified to a 4 and a 2, because 4 times 2 is 8, but the radical 4 is going to turn into a 2 there. Let's separate the t's as well. The 5 and the 2 here are not going to reduce, so I'm going to use t to the 4 and t. And so what happens here is I get a 2 for this, and for this one I'm going to end up with a t squared. So now let's see what I get on the top. I've got this 2 here times this 2 there makes a 4. I've got a t here times t squared there, that's going to be t to the 3rd. Under the radical I still have a 2 and a t. And then on the bottom I've still got my 8t to the 5th. Now when I simplify vertically, let's look at the numbers. 4 over 8 reduces to a 1/2. My t's, I've got t to the 3rd over t to the 5th, so I've got 2 extra on the bottom. And then on the top I've still got my radical 2t. So I don't really need the 1 on top. If you leave it there it's not wrong, it's just it's unnecessary. So then that's my final answer. Square root of 2t over 2t squared. I'd like you to try one on your own. This particular type of problem will be on your next quiz. And so I want to give you one more chance to practice this version before we try another version of rationalizing the denominator. Pause the video and give this one a try. Answer will be displayed shortly. So students can write down this one and mark it as number 13 from the homework. First thing you're going to multiply by is radical 9x to the 5th on the top and the bottom. Remember that what you're doing there is really just multiplying by a 1. On the top the 3x stays, the radical 9 will turn into a 3 here, and the radical of x to the 5th is going to turn into x to the 4 times x to the 1. The x to the 4 turns into x squared, and the plain x stays under the radical. The 3 and the 3 here turn into a 9, but that 9 is going to cancel out the 9 on the bottom. The x and the x squared turns into an x cubed. The x cubed is going to simplify with the x to the 5th, leaving an x squared on the bottom. We still have a radical x on the top, and so radical x over x squared is our final answer. So that's one type of rationalizing the denominator that students need to know how to do, in particular for your next quiz. There's other types of rationalizing, however, and that is the next thing we need to talk about. When the bottom has a radical with something else, we call that an expression. So if there's an expression on the bottom and one of those pieces has a radical, we have to multiply by the conjugate. The conjugate is the same thing that you see, just with the opposite sign in the middle. So we're not making the numbers positive or negative, we're just changing the sign in between them. So the one that we're doing here for our example has a plus, so I'm going to use a minus instead. So I'm going to keep those same bottom numbers the way they are, but instead of a plus I'm going to put a minus. Notice that the top number is not involved at all here. I'm not going to utilize anything about the 8 to move forward. Now because there's a plus or a minus there, I need to handle my multiplication now a little differently from the previous questions. I do need to do the distributive property. I want you to visualize it as if that square root of 6 were almost like a variable. So if I had the 8 out front and then x minus 4 on the interior of the parentheses, I would need to do distributive property. So that's what I'm going to do here. And 8 times square root of 6 is simply going to be 8 square root of 6. And then 8 times the negative 4 is a minus 32. On the bottom, I would technically need to do the full effect of FOIL, but let me show you what happens to the O and the I of FOIL. First let's do the F. F is square root of 6 times square root of 6. Remember from earlier today, when you multiply a radical times itself, the radical cancels. So that gives us just a 6. Now let's look at the O and the I of the FOIL. The O is going to be radical 6 times negative 4, which is just negative 4 with a radical 6 next to it. The inside terms of FOIL are going to be positive 4 radical 6. Think about that like 4x minus 4x. If you add those together, they cancel. So what you can do from now on when you're doing a conjugate, you can skip the O and the I of FOIL on the bottom, because those are always going to cancel out. That's the reason for the conjugate, is we're trying to get rid of those radicals. So then the only other thing we need to do is the L. Make sure you multiply. 4 times negative 4 is negative 16. So now let's just simplify here. On the bottom we know we're going to get a negative 10. I think technically the book wants you to put plain numbers at the beginning and then anything with a radical on the end. Almost kind of like saying 1 plus 2x there. We want the x on the end. One other thing to watch out for on these types of questions in particular is when you can reduce either here or both. And in this case all those numbers are even, so let's divide them all by 2. So if I take 32 and cut it in half, and 8 and cut it in half. I'm not going to worry about the radical 6 because it's just like taking 4x or 8x and cutting it in 2. The x is unaffected. And then on the bottom I'm going to cut the 10 in half so I get negative 5. And now negative 5 doesn't go into anything else on top, so we're finished. I think the book technically wants you to write it as separate fractions. So if you see your answer written that way, know that it's the same answer as what we have. We just put them together instead of separating them. So know that that is an option. So let's practice a couple more like this. We're going to get harder and harder as we go. And I don't want you to try this yet. I want you to try it with me. So our next example has 5 minus square root of 12 over 5 plus square root of 12. So the conjugate that we want to use is 5 square root of 12, and it's the conjugate of the bottom. The bottom has a plus, so we're going to use minus. It has nothing to do with the fact that there's a minus on top. It's totally coincidence. Now we are going to need to do full FOIL on the top and only the F and the L of FOIL on the bottom. So let's take care of the bottom right away because that's going to be nice and easy. 5 times 5 is 25. Square root of 12 times negative square root of 12 is going to be negative 12. Remember that the root times itself equals the number. One's positive, one's negative, so we get a negative there. On the top I'm going to get 5 times 5 for the first terms, so I get another 25. On the outside I'm going to get negative 5 square root of 12. Inside I get the same thing, another negative 5 square root of 12. And then when I do square root of 12 times square root of 12, both being negative, I'm going to get a positive 12. Now let's do some adding of like terms. Plain numbers always add together, so 25 plus positive 12 is going to be 37. And then let's think about these two middle pieces as being like negative 5x minus 5x. Those would be considered like terms, and they'd combine to make negative 10x. So that's what we're going to do here. Except it's going to be 10 square root of 12. Then on the bottom we get 13. Since 13 is a prime number, that doesn't divide evenly into 10 or into 37, so we know we can stop there. However, the square root of 12 can be reduced further. Hopefully students recognize that. If they stopped here, they'd only get partial credit. The square root of 12 can be simplified to 4 and 3. I think we've done that problem enough that students would remember that. The square root of 4 turns into a 2. The 2 is being multiplied by the 10, so our final answer there is a negative 20 square root of 3 over 13. Again, the book, I think, wants you to write them as separate fractions, so we'll do it their way by writing it out separately. But I'm fine with you leaving it as one fraction as long as everything is reduced. I think we have one more to show here, and then we'll be done. So again, we want to multiply by the conjugate. It's the same as the bottom, just with a different sign in between. I have a minus on the bottom, so I'm going to use a plus. Now I'm going to need to do FOIL on the top and the bottom. Keeping in mind on the bottom, I only need to do the F and the L, because the O and the I of FOIL on the bottom are going to cancel. Let's do the top. 2 times 2 is 4. 2 times 3 square root of 5. A lot of students will want to do the distributive property there, but it's not. It's just 2 times 3 times square root of 5. The 2 and the 3 make a 6, and the square root of 5 is just sitting there. So that was the outside terms. Inside terms give me the same result, another 2 times 3 square root of 5. So I get another 6 square root of 5. Now be careful here on this last one. 3 square root of 5 times another 3 square root of 5. This time we're multiplying, and I'm just going to flip-flop these middle two pieces. So this 3 stays, this 3 comes next, the square root of 5 comes next, and then I've got the square root of 5 on the end. So the 3 times the 3 there is 9, and square root of 5 times itself is 5, so I get 45. So that was a lot of work to get that. I wrote it out here just so students could see where the 45 came from. 3 times 3 is 9, square root of 5 times square root of 5 is 5, 9 times 5 is 45. Let's finish off the bottom before we simplify on the top. Remember that we only need to do the F and the L. The F of FOIL is going to make a 4. The L of FOIL is going to make a negative 9 times 5. So that's going to be a negative 45 on the bottom. Now let's do some adding of like terms. 49 plus, remember to think about the adding of the radicals as 6x plus 6x. Can only add when they're the same, so we end up with 12x there, or 12 radical 5. And on the bottom we get a negative 41.